For this question, the airplane with the wings, right, is serving as a conductor, is cutting the magnetic field. So we can apply the motional EMF formula, E equals to BLV. So note that we have to consider, right, the perpendicular component of the magnetic field or the perpendicular component of the length. So I think it's more convenient to consider the B perpendicular. So we will have the B perpendicular here and the B parallel here. Okay, if this is the B. So this will be equals to 1.7 times 10 to the power of minus 4 times cosine 70 degree. So we substitute them into the formula here. So you have the 1.7 times 10 to the power of minus 4 cosine 70 times 26.0 times 250. So the answer will be option D. Here, right, I would like you to also consider which is the positive end of the airplane, which tip, okay? Is it the left or the right? You can pause here first, apply your right hand rule. Okay, if you have tried, right, B field, you have to point your, using your Fleming right hand rule, your index finger point down, the thumb points to the right, and then, right, you'll notice that the middle finger point into the page of the paper, which makes the left wing tip, right, left tip as positive, okay? Furthermore, right, I would like you to consider how come the magnetic field is at an angle to the ground, okay? So let's look at the Earth. So this is just a recap of the EM topic, okay? This is the North Pole and this is the South Pole. So the Earth's magnetic field, right, actually comes out from the South Pole, our geographic south, and enters the North Pole. So it is actually like this. Okay, so just look at two lines. So if you consider, right, someone who is living in the northern hemisphere, so you see, let's zoom in onto this picture here. The shaded region is like the ground. Then you'll see, right, the magnetic field is like coming at an angle to the ground. So this is a B field. If you happens to be at the North Pole, okay, or South Pole, let's look at the South Pole, then you'll see, right, the ground is like this, and the B field, right, is generally vertical. Okay, and finally, right, if you are staying in the equator, okay, you'll see, right, that the B field will be, this is the ground, shaded one is the ground, and the B field, right, will be parallel to the ground level. So this is why the B field, right, will appear as slanted in this diagram.